Hello, my good people. How are you? I hope you're doing well. This is Kate Munyoki once more. And actually, for today, I'm just in the house. I'm actually hiding. So I thought of doing some teaching, of course. So today, actually, I want us to discuss about mass wasting. My good learners, I know this is not new. This is part of Form 3 work. That is the external and forming processes, among the external and forming processes. And just begin by divination. Yeah, I'm saying that I want us to talk about mass wasting. And when you talk about mass wasting, actually, we're simply talking about the downslope movement of materials under the influence of force of gravity. The downslope movement of materials under the influence of force of gravity. Somebody might be asking about this kind of materials. Actually, the kind of materials being moved downslope, that is under the influence of force of gravity. Yeah, actually, the weathered materials, the broken down materials here. So, somebody may ask you to differentiate between mass wasting and mass movement. We have two terms here we need to know whenever we're introducing mass wasting. That is mass wasting and mass movement. And I think I've talked about mass wasting. So allow me to take you through mass movement. What is the difference actually? What is the difference between the mass wasting and mass movement? When you talk about mass movement, we're simply talking about the downslope movement of materials. Yeah. Actually, after such materials have been lubricated by rain or either snow melt. What are we trying to say? The kind of materials which are being moved downslope here, they must be lubricated or saturated with some rainwater or some snow melt. So from there, my good learners, allow me to take you through the factors which influence the nature and speed of the mass wasting, or what is likely the factors which influence the rate at which the materials move downslope under the influence of force of gravity. Factor number one, my good learners, it's actually the nature and the weight of the materials. Factor number two, do you have an idea? It's actually the nature of the slope. Factor number three, we're supposed to talk about the vegetation cover. And the last factor I'm going to take you through, it's actually the level of saturation of the weathered materials. Are you together, learners? Yeah. So let's try to... You can see how actually the land scale movement of materials down the slope. That is under the influence of force of gravity. Yeah. So when you talk about mass wasting, I think we've already said that it involves the movement of the weathered materials, some of the broken down materials without any movement. Yeah. Okay, so my good learners, allow me to explain these factors. Actually, they're the ones we've seen that the ones which determine or influence the nature and speed of mass wasting. So we've mentioned them actually. So I'm going to begin with factor number one. That is the nature, the weight of the materials. So this is what we usually say when we talk about the nature and the weight of the materials here. We say that the heavier and the large materials, like rocks actually, they're likely to move downslope rapidly than fine materials. Are we together? I'm saying the heavier and the large materials, such as rocks, they actually move downslope rapidly than fine weathered materials. Actually, that is what you explain when you try to explain how the following factors influence mass wasting. That is actually how you talk about it. Factor number two, actually, we've said it's about the nature of the slope. The nature of the slope, actually, it might be a steep slope or a gently sloping area. Yeah, a steep slope. Yeah, we're talking about steep slopes. Like, assume we're having some weathered materials at this point here, and they are supposed to be moved down slope under the influence of force of gravity. That is on a steep slope. And we have a gently sloping area of this sort, whereby the materials are likely to move in this kind of slope. So those are two different slopes actually, and the rate at which the materials, the weather materials are going to be moved is actually going to be different. So we usually say the rate of mass wasting is usually faster on the steep slopes. Yeah, it's usually faster on the steep slopes, yeah. Then on the gentle slopes, I'm saying that the speed, the rate of mass wasting actually is fast on the steep slopes. Then on the gentle slopes, simply because the steep slopes encourage the weathered materials to move out at a higher speed compared to a gently sloping area. Compared to a gently sloping area. I think we're together. At that point, I'd say the rate of mass wasting actually is faster in the steep slopes than on the gentle slopes. Compared to the gentle slopes, simply because the steep slopes, they usually encourage the weathered materials to move at a high speed than gentle slopes. Yeah. So the other factor we're supposed to talk about actually, you can see my So the other factor actually is about vegetation cover. We had mentioned about it here earlier. Vegetation cover. When you talk about the vegetation cover, we're simply talking about a vegetated area and bare land, or an area with dense vegetation and another area maybe with no vegetation or without vegetation. So when you compare those two different areas, actually the rate at which the materials are likely to move down slope actually is going to be very different. I don't know whether you agree with me. Let's see this. Actually, the rate of mass wasting, we expect the rate of mass wasting to be a bit higher, faster, to be rapid in areas with no vegetation than areas which are having some dense vegetation. Why? We are saying lack of vegetation actually reduces the ability of the soil to hold. Yeah, the lack of vegetation actually reduces the ability of the soil to hold together, encouraging easy and faster mass wasting. So what am I trying to pass out? What am I trying to say? I'm saying that the rate of mass wasting actually is high in areas with no vegetation, or with less vegetation than areas with dense vegetation. The other factor, my good learners, actually is about the level of saturation of weathered materials, the level of saturation of the weathered materials, the level of saturation of weathered materials. When you talk about saturation, we're simply talking about the more these weathered materials are having water, how they saturated, have they taken more water such that they are a bit heavier, the level of saturation. So we usually say the highly saturated materials actually move down slope easily and faster than dry weathered materials. What am I trying to say? That highly saturated materials, the materials which have already absorbed a lot of water, of course we expect them to be a bit heavier. So they're likely to move down slope rapidly and faster than the dry weathered materials, which are actually less dense. They are not heavier, so there is nothing triggering them to move down slope. So I'm trying to say that the highly saturated materials move down slope easily and faster than the dry weathered materials. Are we together, my good learners? So far, how many factors have we talked about? Remind me. We've talked about around 4 so far, and I believe we still have the last one about the climate of the area. So, the last factor, my good learners, is actually the climate of an area. The climate of an area, actually different areas experience different climates. Do you have climates? Baby, do you know the difference between weather and the climate? I believe you do. If you don't, a topic for another day. So I'm saying that my last fact actually is about the climate of area. of an area. We know that there are areas which experience high rainfall, there are areas which experience low rainfall, there are areas which experience high temperatures, there are areas which experience low temperatures. So whenever I talk about climate, actually, it's a general term which is usually described by things like rainfall, things like temperature, things like sunlight, things like wind, and so on. So we see that areas receiving high amount of rainfall, they experience rapid mass wasting, simply because water is likely to act as a lubricant. So the water acts like a lubricant that is on the surface compared to those receiving low amount of rainfall. Yeah, we are saying that areas experiencing or receiving high amount of rainfall, actually, they experience rapid mass wasting simply because the water acts as a lubricant. Lubricant. What am I trying to say? On the surface, compared to those areas which experience low rainfall. Yeah, so that is the last factor. I think they're around 5, if I'm not wrong. We've talked about the weight of the material, the vegetation cover, the level of saturation of the material, the nature of the slope, and finally, I think we've talked about the climate of an area. So from there, my good learners, we shall be talking about the types of mass wasting. Types of mass wasting, actually. We have 2 types of mass wasting. Anyone? Of course, we have slow mass wasting, and we have number 2, rapid mass wasting. Slow mass wasting and rapid mass wasting. So that is what we shall be discussing. That is in the next lesson. We see whereby the materials are likely to move slowly. In some other cases, they move a bit faster. So we have 2 types of mass wasting, my good learners. So without wastage of time, my good learners, allow me to say bye. See you in the next video. And thank you so much for your time.